Welcome back. In this lecture, I'm going to discuss about moments. Moments are nothing but statistical averages of a random variable. There are two types of moments. The first one is moments about origin or moments about zero mean. Moments about zero mean. The second kind of moment is moments about mean. Moments about mean. This is also called as central moments. These are represented moments about origin are represented with small m. Moments about mean or central moments are represented with mu, with order n, suffix n, and here also suffix n. The moments about origin mn is equals to expectation of the random variable x power n. And coming to the central moments, mu n is given as it is the expectation of x minus x bar whole power n, where x bar is a mean value of a random variable x. This mean can be represented as mx also. Now let us see one by one. Moments about origin. Yes. Just now we have seen it is written as mn, representation is mn, it is expectation of x power n. We can apply this expectation of n for two kind of random variables, continuous random variable and discrete random variable. For continuous random variables, it is integral from minus infinity to plus infinity x power n fx of x dx. Here the random variable is continuous random variable. And coming to the discrete case, it is summation over I xi power n pxi. Here it is discrete random variable. If you can clearly observe, whatever is inside x power n, that presents here and that presents here. If x power n, x square is there, that x square sits inside of integrals or inside of summation, and the density function will come into picture for continuous random variables, and pxi is nothing but a probability mass function that comes into picture for discrete random variables. Now let us see one by one, where here n equal to 0, 1, 2 up to so on. Now let us take n equals to 0. So for n equals to 0, m suffix 0 is equals to expectation of x power 0. Let us consider a discrete or a continuous random variable. Let us consider a continuous random variable. Integral from minus infinity to plus infinity x power 0 fx of x dx. This is equals to x power 0 is 1. So integral from minus infinity to plus infinity fx of x dx. So this is area under PDF. Area under probability density function is always equals to 1. For 0 order, this m0 is equals to 1. Okay, 0 order. Now coming to n is equals to 1. So we call this as first order moment about 0 mean or origin. 0 mean or origin. So here m1, we have to write m1 is equals to expectation of x power 1, or simply m1 can be simply written as m is equals to expectation of x. This is we call this as a mean. The first order moment about origin is called mean. This itself is the definition of mean. So let us write this mean for continuous random variable and discrete random variable. For continuous random variable, it is integral from minus infinity to plus infinity x fx of x dx is for continuous random variable, and integral becomes summation for discrete random variable. So summation over I xi probability of xi. This is for discrete random variable. Let us see a problem. Find mean of random variable x. Find mean of random variable x. Here a table is given. X, the values are from minus 1 0 to 1, and their probabilities nothing but probability mass functions. So 1 by 3, 1 by 3, 1 by 3. For this we have to find the mean. Solution. Here x is discrete random variable because the probabilities are given. X is a discrete random variable. So for this mean, formula is summation over I. Here I is from minus 1 to 1. I equals to minus 1, I equal to 0, and I equals to 1. Xi probability of xi. So let us expand this. X minus 1 multiplied with its probability x minus 1 plus x0 multiplied with probability of x0 plus x1 multiplied with probability of x1. X minus 1, the value of x minus 1 is minus 1, and the probability of x minus 1 or x equal to minus 1 is 1 by 3 plus x0 is 0, and probability of x0 is 1 by 3 plus x1 is 1, probability of x1 is 1 by 3. So here it leaves us minus 1 by 3 and plus 1 by 3, both are equal and opposite. So the mean value of the given problem is 0. So whenever we find mean for a given discrete random variable, we should multiply with the random value with its probabilities and add those all probabilities. Here the first one is minus 1 into 1 by 3, second one is 0 into 1 by 3, third one is 1 into 1 by 3. Add all those, that gives us the mean. Let us see one example for continuous random variable. Find mean of a uniform random variable. Find mean of a uniform random variable over interval 0 to 5. Over interval 0 to 5. So here density function is given, or uniform random variable is continuous random variable. Let us say uniform random variable is continuous random variable. So let us write the formula for mean. M is equals to expectation of x, and that too for continuous random variable, integration from minus infinity to plus infinity, x fx of x dx. So we don't know what is the density function fx of x, but here x is given as uniform random variable over the interval 0, 5. So before that, let us know what is a uniform random variable. A uniform random variable, x-axis is x and y-axis is fx of x. Its density is constant over some interval. The density function maintains constant value over some interval a to b, and this constant value is 1 over b minus a. So here the density function of a uniform random variable is 1 by b minus a, where the x is from a to b. Now coming to the problem, a is given as 0 and b is given as 5. So the density function fx of x is equals to 1 by b minus a, 1 by 5 minus 0. So this is 1 by 5, and the range of the random variable is from 0 to 5. Now let us apply this in the formula. So the mean is equals to integral x fx of x is equals to 1 by 5 dx. So integration with respect to x. So how to find the limits of integral? That depends on the range of the random variable or the density defined over which values of x. So in this problem, uniform random variable is given. The uniform random variable is defined from 0 to 5. So the lower limit is 0 and upper limit is 5. Or the range of this random variable is 0 to 5. So m is equals to, write 1 by 5 outside and integration from 0 to 5 x dx. So 1 by 5 integration of x is x power 2 by 2 factorial from, sorry, it is not x 2 factorial, it is x power 2 by 2, x power 2 by 2 from 0 to 5. So on applying the limits 1 by 5, so 5 square by 2 minus 0 square by 2, so 1 by 5, 5 square by 2, 1 5 gets cancelled, 2 1 ja and 2 2.5. So the mean of the given problem is 2.5. This way we have to find the mean. And let us know the properties of mean. Properties of mean. The first property is expectation of constant is always constant, k is the constant. The second one, expectation of some k times x is expectation of k times expectation of x. And the third one, expectation of some ax plus b is equals to a times expectation of x plus b. So from this you can understand that the expectation is applied on the random variable. Now here let us prove this expectation of ax plus b. Let us distribute this expectation on ax term and b. So it gives us expectation of ax plus expectation of b. From the second property it is written as a expectation of x. From the first property it can be written as b. So on the whole, the expectation is applied on the random variables to find the statistics. So for, there is no statistic for constant. The constant is always constant, it doesn't vary. And the fourth one, if we consider two random variables, it is the expectation of x plus or minus y. It is nothing but expectation of x plus or minus expectation of y. This way we have to find. Now if I give you some function g of x, if I give you the function g of x, then what is the mean of g of x? What is the mean of function of a random variable? What is g of x here? It is a function of random variable. Function of one random variable. It's a very simple concept. Mean is the first order moment about origin. So expectation of, we have to write g of x. It's the first order, so you have to write g of x. If it is a second order, we have to write g of x whole square, but it is a first order, just write expectation of g of x, right? So for continuous random variables we can write it as integral from minus infinity plus infinity g of x fx of x dx. This is for continuous random variable. It's okay. Thank you.